Hello, everyone. So this is our first lecture. So this semester, we will cover the material between chapter 7 and chapter 13. Before we started the new material, let's do some review what you already studied in Tag 1. Okay, that's about the formulas of integral or indefinite integral. Okay, the first one is, okay, the integral dx is x power to n plus 1 over n plus 1 plus c. C is a constant. And here n is not a negative one. Okay, this is our first one. And the second one is 1 over x dx. The antiderivative is log n, absolute value of x plus c. So one thing here is about, don't forget the absolute value. Why? Because x can be negative. If you forget the absolute value, log n, x is a negative, it is illegal, right? So here, if you compare two formula, n equals to -1 is so special. I don't know why, just that's math, right? Just, you remember it, okay. And the third one is, okay, ex, the antiderivative is ex plus c, okay. And the third one is bx dx, this is bx over ln b and c. Of course, b is greater than 0. You can say 3 is a special case. No, sorry. 3 is a special case of 4, right? When as b equals to e, right? 4 is 3. Okay, that's what I want to say. Okay, so the third one, the fifth one, sorry, is sine x dx. The antiderivative is negative cosine x plus c. Okay, 6 is cosine x dx is sine x plus c. And 7th is secant x dx is tangent x plus c. 8, cosecant x dx is negative cotangent x plus c. If you already forget the trigonometric function, please check the textbook, or check, what you studied last semester. It's very important. Okay. So the ninth formula is secant x times tangent x dx. The antiderivative is secant x plus c. 10th is cosecant x cotangent x. The antiderivative is negative cosecant x plus c. Okay. 11. This is about sine hyperbolic x dx. So this is cosine hyperbolic x plus c. 12 is cosine hyperbolic x dx is sine hyperbolic x plus c. You may ask me what's sine h x cosine h. The definition, I just remind you, is sine h x is half ex minus e negative x. The definition of cosine hyperbolic function is hx, which is half ex plus e negative x. Just remind you. Okay, one more is 13. This is the antiderivative of tangent x dx is ln absolute value secant x dx plus c. Okay, 14 is cotangent x dx. So we say the antiderivative is ln sine x absolute value plus c. Okay, fifth formula is 1 over x squared plus a squared dx. The antiderivative is 1 over a. Of course, a is not 0. Okay, if a is 0, this is the case 1, the first item. Okay, this is 1 over a times tangent negative 1 and x over a plus c. Or sometimes the people write a tangent x like this is arcotangent x. No, that it depends on the lecture. Different people use different notation. Okay, they are the same. That's like what I said. They are the same, just the same thing. The people use different notation. Okay, 16. This is 1 over a squared minus x squared dx. A is not 0. Like what I said, if a is 0, this is case 1. The first one, no, the first item. Okay, so this is sine negative 1 x over a. So plus c here, a is greater than 0. Okay, like what I said. So here, some people write sine negative x as arc sine x. Just a notation. That's not a big deal. Okay. For all of this formula, I think you should memorize it. So I write a remark. You should be very familiar with this formulas, because we will use this formula to compute the antiderivative for a complicated function. That's our goal for this semester, right? So if a function is complicated, how do we find the antiderivative? If you are not familiar with the formulas, you won't know how to get started. Our kind of the procedure is like this. Okay, we have a very complicated function, and then in this course, I teach you some technique or skills, and then you convert that complicated function into the standard function listed here, and then you can get the antiderivative directly. I hope you understand me. This kind of formulas are very important. We will convert complicated function to our function listed here, and then you can find the answer directly. Okay, so this is about the formulas we studied, I think last semester or Calc 1. So we already talked about the formulas for many functions, and also all our formula are about the indefinite integral. So in the second part of our view, this is part 1 and the part 2. So we'll talk about the definite integral, right? So the basic question is a b fx dx. So how do we compute it? I think last semester we studied this. We're in Calc 1. So how do you compute it? There is a formula like this. Okay, the formula says this is fb minus fa. So what's f? Here, if where f is any anti-derivative of fx. Here we have something. We assume fx is continuous on the interval a, b. Of course, b is always greater or equal to a, right? It's kind of, that's our notation. Okay, so this is called the fundamental theorem of calculus. Okay, this is part 2, right? You can check the textbook, page 396. Okay, oh, this part 2 is not this part 2. Okay, that's different. Okay. And also, we have another formulas we studied. Last semester, the formula is this. We still assume f is continuous. We define dx is ax ft dt. So it's kind of, let the upper bounds be changed, right? We write it as x. It's a variable. So this is the function, right? And the x is between b and some a, and the our result is okay. Gx is differentiable. Gx has a derivative, right? On a, b, and like what I said, G is differentiable. The basic question is that what's the derivative of G, right? So this formula tells us, okay, the derivative of G is fx. Okay, so this is called the fundamental theorem of calculus, part 1. So it's kind of, this part 1 is corresponding to part 2, because I used the, part 1 and part 2. Anyway, the name is not important, just know these formulas. I think we will use this semester. It's very important. Okay, so I think you should know, these formulas for this semester. Okay, if you have any question about this, you can come to my office hour or send me an email. I would be very happy to answer your any questions. Okay, I'll stop our review recording.